So these questions which you'll see will involve partial fraction while you're solving for the integrals. Only such questions are assessed in higher level maths. Now, what's most important out here is that you don't have any formulae that can help you directly integrate these. So what we need to do is we need to learn certain techniques by which we can integrate this. So obviously in our binomial units while we were doing, we did understand how to expand using partial fractions and all. So now let us say if I have uh, 1 over x plus 1, x plus 2. First thing what you'll do is generally there is a follow-up question that express this as a partial fraction or something like that. So what we'll do is first we'll express each of these into their partial fractions. So obviously these are distinct roots. So you take a over first root plus b over the second root. Now to evaluate after this, what we do is you cross multiply x plus 1, x plus 2 other side. So it'll be 1 over a over x plus 1 times x plus 1, x plus 2 plus b over x plus 2 multiplied with x plus 1, x plus 2. Now as a result, x plus 1 get cancelled. Here x plus 2 get cancelled. So what we get is a times x plus 2 plus b times x plus 1. Now, of course, here there are two techniques by which you can do this question is by substituting for their roots, like for individual x plus 2, for example, if I take, let's say, x plus 2 equals to 0 here. Now indirectly you take x is negative 2, both the sides if you put, it'll be 1 equals to a times negative 2 plus 2 plus b times negative 2 plus 1. And this become anyway 0. This will be 1 equals to b times negative 1. And so we get b is negative 1 actually. Once you got b is negative 1, you plug in x is negative 1 here. Okay, so you take basically once you make this bracket 0, once you make this bracket 0. So if I take x equals to negative 1 both the side now, so we get 1 equals to a times negative 1 plus 2 plus b times 0. So this is 0. So a equals to 1. Now that's your basic integral, a equals to 1 here. Now actual answer when you get. So I can integrate this 1 over x plus 1, x plus 2 by rewriting this as a, which is 1 over x plus 1 minus, or b is x plus 2 basically. Negative x, b is negative 1. So that's how I get this. Now you couldn't integrate this, but now you can integrate this part, which is nothing but integration of 1 over x plus 1 is ln of x plus 1 minus integration of, and here the coefficient of x is 1, so we're dividing by 1, so it doesn't make any difference, minus ln x plus 2 and plus c. So this is gonna be the integral of the given this particular expression. So when you talk about the second integral, let's say integration of 1 over x squared minus 9, lots of kids get confused with this one. So it's if you factor out the denominator, you can see that it is integral of 1 over x minus 3, x plus 3. So this is like any other question. Now what we'll do is we'll express this as a partial fraction first. So we express it as x minus 3, x plus 2. This is a over x minus 3 plus b over x plus 2. Now what you do is you once again you x plus 3 here. This is x plus 3. Now you cross multiply, so it'll be 1 equals to a times x plus 3, because x minus 3 get cancelled, and plus b times x minus 3. So once again, you can take x as negative 3. If I take x as negative 3 here, this becomes 0, but other bracket will be b times negative 3, which is b equals to 1 over negative 6, which is negative 1 over 6. Now similarly, take x is positive 3. If I take x is positive 3 here, 0. So you get a is 1 over 6. because it'll be 3 plus 3, and this will be 0. So a times 6 will be 1. So a is 1/6. Now, so the same thing can be written as 1/6 x minus 3 plus, minus 1/6 x plus 3 in the denominator. And now you can take 1/6 out. 1/6 is can be taken out, which is x minus 3, and then minus 1 over x plus 3 dx. Now, when you integrate this, it'll be 1/6 ln x minus 3 minus ln x plus 3. Since you don't know the range of x value, so it's better to keep this absolute value. And of course, plus c. So now, this question a little different compared to the other one which we did. So here, if you see, there is a repeated factor in the denominator. So the only difference that comes is while you express this as a partial fraction. So since we have the general format, if you have a repeated factor in the denominator, we first write down the first root, single power. So a over x minus 1 plus b over x minus 1 squared plus c over x plus 2. So this is the basic formula that we in basics backbone structure. So if it is cube, you would take c over x minus 1 the whole cube plus d over x plus 2. So just be informed about this kind of question. Now, if you cross multiply, you get x will be a times, I'll just rewrite this, x minus 1 here, x minus 1 the whole square, x plus 2. You basically are going to multiply each term by this, b times x minus 1 the whole square, x plus 2, and also x minus 1 the whole square is here, plus c over x plus 2. And what you have is x minus 1 squared, x plus 2. Now, from first one, you get cancel this part, from second one this part, x plus 2 from this. So as a result of this, what we get is a times x minus 1, x plus 2, plus b times x plus 2 plus c times x minus 1 the whole square. Now at this stage, once again, you can try to make one of the brackets 0. So if I take x is 1, both the sides, you get 1 is a times 0 plus b times 1 plus 2 plus c times 0. And you get, as a result of b is nothing but 1/3. Similarly, now let us take one of the other bracket as 0. If I take x is -2 both the sides, you get -2 equals to a times 0 plus b times 0 plus c times -2 minus 1 the whole square. So you get -2 equals to c times 9. So c that you get is actually -2 over 9. Now, once you got c, now we don't have any other factor that we can use or put in the expression to get the value. So what we do is we use the other method, which is the comparison of the coefficients. And the easiest coefficient that looks me is that, okay, what I can do is when I expand this, I'll get ax squared term, because if you open this up, it'll be x squared minus plus x minus 2. So I just take x squared term of that, and similarly I take x squared term of this. There is no x squared term here, so the resulting expansion, this expansion, will have a plus cx squared as coefficient of x squared, a plus c as coefficient of x squared. And because you can see that there is no x squared term here, so I would equate a plus c to 0. Now, since you got c as -2 over 9, so a minus 2 over 9 equals to 0. So that gives us a is 2 over 9. So once you got a, b, and c values, you put them at their places and rewrite this integral as, this can be written as a is 2 over 9, so 2 over 9 x minus 1 plus integral, I can isolate in the beginning itself, b is, we got 1/3, so I could take 1/3 outside, and 1 over x minus 1 the whole squared, and you can attach dx here, don't forget, if you're writing them separately. And third is c, which is once again -2 over 9. So I can take -2 over 9 outside and 1 over x plus 2. Now comes the final step, is integration. So what I'm going to do is I'm going to integrate this as 2 over 9 integration of x minus 1 dx, which is going to be 2 over 9 ln x minus 1. And similarly, this is negative 2 over 9 ln x plus 2. But this problem is here. This is not going to be ln, so you're going to integrate 1/3. First, take it up as x minus 1 is to negative 2. And once you integrate this, it'll be 1/3 x minus 1 to the power negative 1 over negative 1, and divide by the coefficient of x, which is 1. So plus c. Now if I put up all together, it is going to be, the final answer will be 2 over 9 ln x minus 1 minus 1/3 x minus 1. If you take this in denominator, plus, minus 2 over 9 for c part, minus 2 over 9 ln x plus 2, and final answer is plus c. So this is your final answer for the integral. So when you look at the basic structure here, it's a little lengthy, but if such questions are asked, it'll be definitely for heavy marks. So just, it's worth understanding and doing it. So now let's say when you are integrating 2x minus 3 or x squared minus 1, 2x plus 3, obviously once again it is going to involve partial fraction. So we can factor out x squared minus 1 as x minus 1 x plus 1. So it's going to be a over x minus 1 plus b over x plus 1 plus c over 2x plus 3. And find out the values of a, b, and c, like as per the given values. Like here, x, if I take x is minus 1, this becomes 0, this becomes 0. So you get this one becomes 0, this becomes 0. So you get the value of b as negative 5, positive 5 over 2. Then similarly, if I plug x as 1 here, so you get this as 0, this as 0. So you get value of a as negative 1 over 10. And then you can find out the value of c also. So by plugging x as negative 2, negative 3 over 2. So once you get the value of a, b, c, you can just rewrite this. Instead of a, I can put it as negative 1 over 10. So this will be, let's say I would put negative 1 over 10 here. And then b values 5 by 2. So it will be 5 over 2 here. And c is negative 24 over 5. So when you put the final integration, it's going to be, I'll just erase this part. So the final answer when you take it is going to be negative 1 over 10 ln x minus 1 plus 5 over 2 ln x plus 1 minus 24 over 5 ln 2x plus 3, but don't forget to divide by coefficient of x. Here coefficient x was 1, but here it is coefficient of x is 2. So do not forget to divide by that. So this is going to be the integration of this particular fraction.